Before we introduce you to generative AI, it's important to understand the most common types of machine learning techniques. Let's start with supervised learning. Supervised learning is a technique in which every training sample from the dataset has a corresponding label or output value associated with it. As a result, the algorithm learns to predict labels or the output values. For example, let's take a dog versus cat classifier. So from a solution standpoint, if you want to build a dog versus cat classifier, you can use Amazon SageMaker to build the model and AWS DeepLens to start inferencing in real time to identify a cat versus dog. In unsupervised learning, there are no labels for the training data. The algorithm tries to learn the underlying patterns or distribution that governs the data. Clustering, for example, is one such technique in unsupervised learning. The generative AI techniques used in AWS Deep Composer understand the underlying pattern distribution in the music to generate newer ones. And the last one is reinforcement learning, which is a technique where the agent learns through the consequences of action on a specific environment. You can get started with reinforcement learning using AWS Deep Racer. With AWS Deep Racer, you can get hands-on with a fully autonomous 1/18th scale race car driven by reinforcement learning, 3D racing simulator, and a global racing league. So now that you know the different machine learning techniques, let's look into generative AI. Generative AI is one of the biggest recent advancements in artificial intelligence because of its ability to create something new. It opens the door to an entire world of possibilities for human and computer creativity, with practical applications emerging across industries, from turning sketches into images for accelerated product development to improving computer-aided design of complex objects. Generative AI technique pits two different neural networks against each other to produce new and original digital works based on sample inputs. So how is generative AI being used today? Starting with Airbus, as part of an ongoing effort, Airbus is reimagining multiple structural aircraft components, applying Autodesk generative design to develop lighter weight parts that exceed performance and safety standards. At 35 million miles, the trip to Mars is short compared to the 365 million miles journey to Jupiter. And then Saturn is another 381 million miles past that. Getting landers to these distant areas presents far greater design and engineering challenges. To meet those challenges, JPL and Autodesk have engaged in a multi-year collaborative research project so that JPL can explore new approaches to design and manufacturing processes for space exploration with the custom application of Autodesk's generative design technology. Now to more human applications such as what Glidewell Dental is doing. It wasn't long ago that dental crowns or caps were produced on assembly lines with rows of workers engaged in the physical effort of building and shaping them. Glidewell Dental is training GPU-powered generative adversarial networks, which are adept at reconstructing detailed 3D models from images. More specifically, they are combining depth maps of the crown design with GANs, in which one network generates images and the second inspects those images. This results in crowns that have even more anatomical detail than the original teeth they are replacing. The really exciting element of these examples is how machine learning is creating something original. By teaching the machine learning model what a good structure is, for example in the Autodesk example, or a good tooth looks like for Glidewell Dental. And then generating new content, optimizing for those constraints, in a way a human designer might never think of.